And 2 years later, 3 years later, 4 years later, 5 years later, it comes back with a vengeance. It's metastasized to the bones. At stage 4, they say, I'm sorry, there's nothing we can do for you. Why is that? It's because it's already proven scientifically that chemotherapy doesn't kill the cancer stem cells. And the cancer stem cells, just like our body's innate immune stem cells, are very similar, where the cancer stem cells self-regenerate and self-replicate. So even if you have surgery, you have chemotherapy, and they say the cancer is gone, the reality is what has just happened is you just pissed off the cancer. And those cancer stem cells will start replicating and spreading. And anybody tuning in probably has known somebody or has heard a story of somebody who this exact same thing has happened. It came back years later. Why? Because they didn't change all the underlying causes. So those cancer stem cells start replicating, and spreading everywhere, because cancer is not something trying to kill you. This is what we have to understand about cancer. It's not an invader that's trying to kill you. Cancer cells are actually very weak cells. They produce very low amounts of ATP. They're very inefficient. They don't go through the glycolysis process very well. I look at cancer cells like these little weak cells hanging on the side of a cliff, like hanging on for dear life. Like they don't want to die, right? They're trying to survive, just like every other cell in your body is trying to survive. Well, if they're given the perfect environment, then they are going to survive and to replicate. And that environment is acidic environment, anaerobic means low oxygen, a high stress, high inflammatory environment. Then those cancer cells are going to thrive. But what they're doing is they're just trying to stay alive, trying to keep you alive. And when you have a tumor, for example, say you have a tumor in your breast or anywhere, that tumor is actually extending your life. It's encapsulating all those cancer cells. So when you go in and you poke at it with a biopsy, you just release millions of cancer cells throughout your bloodstream and your lymphatic system. Ooh, that's dangerous, right? When you go in and you start cutting in and around it, you're basically pissing it off, right? You're taking it out, and all those cancer stem cells are now they're super aggressive now, because now they're trying to really stay alive. So they ramp up their angiogenesis and their reproductive qualities and all these things. And so we have to understand cancer is it's not this invading enemy that you have to attack and kill and destroy. It's actually a symptomology of lifestyle that needs to be improved upon. And if we learn to improve upon the lifestyle that caused the cancer in the first place, then ideally and hopefully we can stop the spread of it, and in some cases even reverse it. So it's a different mindset we have to have about cancer, because it's not this hereditary thing that's attacking you, that's trying to destroy you. It's trying to actually keep you alive. It's trying to keep itself alive. And in the process, it can kill you. But actually most people don't even die from cancer. Most people die from the treatments causing a weakened immune system, and then dying from some other infection or from malnutrition, actually. Or heart disease or heart attack or something else. It's actually more people die from that than from the cancer itself.
When you perhaps get cancer at age 70 or 75, the contributory effects of your diet style your whole life, even what you ate as a child, has some effect on that. And so we're talking about people improving their nutrition to protect their immune system so we can win the war on cancer. We've got the problem licked already. We can win the war on cancer right now. The evidence is overwhelmingly, and we have thousands of studies that corroborate each other. You literally don't have to get cancer, but you can't just change your diet when you're 75. We have to change the whole way society eats so we can affect the diet style of all ages of people, and then we can dramatically see tremendous reduction in obviously cancer rates. And right now this year we've had a tremendous crisis with people dying of COVID, and everybody knows that it's hitting the most vulnerable people are people who have poor immune function and people who have poor nutrition and have medical conditions and are overweight.
Nature came out with a massive study, and they said upwards of 90% of cancer is diet, lifestyle, and environment. Right, so already, here we go. We've got close to 95% of cancer that is basically not hereditary. 90%, upwards of 90% of cancer is diet, lifestyle, and environment. And then you add in the incredible science of epigenetics. Bruce Lipton says this famously. He says, if genes cause cancer, then why do 50% of women with the BRCA1 gene never get cancer? Right? So just double mastectomy out of fear is actually destroying people's lives, because 50% of women with the BRCA1 gene never even get cancer. So it's not the genes that cause the cancer, right? Epigenetics tells us that it's the environment in which the cells live that will change the expression of those genes.
The most difficult question to answer that everybody wants to know for themselves and their loved ones is, what's your success rate? What's the chance that I have to overcome this? And people ask that question largely because they're not given a lot of chances. We get a lot of patients coming to us that are stage 4. Most people don't go, hey, I just found out I have stage 1 breast cancer. I think I'll go an alternative route. More people are doing that today, but we don't see that as common. When we hear that we have cancer, typically, that's an extremely scary word. Our sympathetic drive goes through the roof. It's like a polar bear is chasing us. And it's hard to think clearly. It's easy to just follow a pathway that we're told to do. We need to get a port put in. We need to get chemotherapy going. We need to schedule for radiation. And it's hard to think of alternatives at that point.
So in my practice, the division of patients is about half cancer and half chronic illness. Those two big areas of medicine have a lot of crossover. So people with cancer, people with chronic illness have some things very much in common, and some things are very different because cancer is its own entity. A lot of people want to know what our impression is of the role of genetics in chronic illness or cancer specifically. What's interesting is while genetics play a role in everything that we have in our lives, statistically, under 10% of cancers are truly genetic problems. So you definitely see, unfortunately, one of our populations is pediatric cancers. And in pediatric cancers, you will see children literally born with a cancer from a genetic issue. But as you get through the rest of the lifespan, what you tend to see is a very small number are truly genetic. Most are metabolically induced, immunologically induced, sometimes drug induced, and then sometimes many, many other things as far as where the cancer would come from. One thing that sort of overlies this is while genetics might be a small percentage of true cancer cause, how our genes are set up to make us resistant to infections, how our genes are set up to help our metabolism work, those things can all be contributory. So they're maybe not causing it, but if, for instance, we have a lot of genetics that make our sugar metabolism inappropriate or make us more inflamed, if we don't do something about those, they make us more likely to develop cancer. So it's a complex issue and something that is often confusing to people, I think. And there's a lot of new research talking about cancer stem cells and how they're really more of the problem once things get going, is that cancer stem cells have kind of two states of being. One is very quiet and not doing anything. The other is active and recruiting. What you don't want is active and recruiting, because you could, for instance, do a radiation therapy or cut out a tumor. That tumor's gone, but the stem cells nearby will go to sleep till you're all done treating it, and then they will sort of, in a way, reanimate and recruit neighboring cells to become more tumor. So if there's a way that you could get the benefit of removing one tumor and then keeping the stem cells from waking back up, that's the best of both of those worlds. And that's in the case where you already have a cancer, not in the pure prevention case.
Genes do